Hi, my name is Dr. Shaktivel Murugan, Assistant Professor in the Department of Mechanical Engineering, Kamaraj College of Engineering Technology, Virudhunagar. Today I am going to discuss about the topic in the subject Engineering Graphics, which is a common subject to all the first year students. So particularly we are going to discuss today about the topic known as perspective projections. So most of the engineering colleges, they are focused on the isometric projections, but when comparing to isometric projections, the perspective projection is very easy, and also it is very easy to draw when compared to isometric projections. Usually isometric projections may take several hours time to complete the entire drawing in a neat manner, but if you understand the concepts of perspective projections, it is easy to get marks in this particular topic. So today we are going to discuss deeply about the perspective projections. So before going to discuss the technical aspects of the perspective projections, first the elements of perspective projections is very important. Without knowing these elements and the terminologies, it is very difficult to understand the problems which are given in the perspective projections. And these are the major elements of perspective projections. The first one is ground plane. The next one is stationary plane. So here I have shown all these types of planes in a three-dimensional representations. So the first one is ground plane, means the plane which is displayed in this yellow color. This plane is known as ground plane. So imagine a person is standing over the ground plane. So this is what the plane. So this is the yellow color plane, is a ground plane, and the next one is station point. So imagine the eye of the observer, because this person is an observer. So look at the eye. So here this eye point is known as the station point. So mostly in the perspective projections, the station point is given. It means a person standing over a ground plane and his eye contact is simply referred as the station point of the particular object. Because if you look at any object, the person standing in this room, it may vary based upon the person standing and looking at that objects. If I am standing and looking at the object, I could able to see only portion of this object. At the same time, if my standing position is changed and if I see the same object in some other orientation inside the room, then the shape of the objects may be varied. So the entire output of the three-dimensional output of the drawing is completely depends upon the station point, that is the eye contact of the particular observer. So that is the station point. Then the picture plane. This is the very important plane. So here the plane which is perpendicular to the yellow color plane, this plane is known as picture plane. So here see the plane, this is the yellow color plane, this plane is perpendicular to this. So for example I will explain. This is the plane, this is the plane which is perpendicular to the yellow color plane. That plane is known as the picture plane. Then the horizon plane. So here what is horizon plane? So the horizontal plane, the plane which is represented in this pink color, this pink color plane is known as horizon plane. Then the auxiliary ground plane. So the auxiliary ground plane is not needed, so that is mostly represented green color, which is not much importance in this particular topic. So then the ground line. So these are all the planes. If you understand these planes, then I will explain you about some important lines, that is ground line, the line. So when you look at from this directions, some of the lines are important. So when you see from the front view, when you look at the front view, so here the line, when you look at the front view, this line, this base line is represented as ground line, and the horizon line, when you look at the line in the front view, that is if you look at this horizon plane, that is the plane in pink color, if you look at this plane, the line which is formed on the horizon plane is known as horizon line HL. So this is HL, and the perpendicular axis is nothing but this is your perpendicular axis. That is exactly, if a picture plane is segregated into two halves, that plane of the observer is known as perpendicular plane. Mostly this perpendicular, if it is the eye contact of this particular person, the perpendicular axis is always perpendicular to the picture plane. So that is known as the perpendicular axis, and the center of the vision is, this point is known as the center of the vision, and the central plane is, this perpendicular axis forms one plane, that plane is known as central plane. So this is the concept. So firstly I will recall. So these are the planes, that is ground plane, horizontal plane, and this is picture plane. and the basic lines is ground line, station line, and the eye contact of this observer is known as station point. So mostly these are all very important aspects to understand about the perspective projections. Okay. Now you know about the basic elements of this perspective projections. Now I am going to explain about the concept behind this. Okay. So if suppose a object which is lies behind the picture plane, if it is the picture plane, an object which is located behind the picture plane, this is the object which is going to locate behind the picture plane. Now you imagine, so if you imagine that this is the plane of projection, this is first angle, this is second angle, and this is third angle, and this is fourth quadrant. This is first quadrant, second quadrant, third quadrant, fourth quadrant. If an observer is lying here, so here it is this is the eye contact of the observer. So if we are going to look at this particular object which is behind the picture plane, this is the picture plane, this is the picture plane, an object is located here. So here in this perspective projection, the object is always lies on the third quadrant. So the object always lies on the third quadrant. If you look at this, if you are able to make up projections, always the projections, it must be in third angle projections in this particular perspective. What is third angle projections? So here, this is your reference line XY. So here you will get the top view, and below this reference line you will get a front view. So earlier in all the topics of engineering graphics, you have drawn only the first angle projection, that is above the reference line you always draw the front view, and below the reference line you always draw the top view. But in this particular topic, perspective projections, the object is lies behind the picture plane, therefore the object is lies in the third quadrant. Therefore whatever the projections that we are going to draw, that particular projection, it's always in third angle projection, that is the front view should be drawn below the reference line and the top view is drawn above the reference line. For this the terminologies may be differ. So this is the basic concepts in perspective projections. Now we are going to let us discuss the perspective projection with a simple example problem. Okay. So this is an example problem. So we are going to discuss a square prism. So a square prism is given, of base, side and height of the prism is given, and with it rest with its base on the ground such that one of its rectangular faces is parallel and 10 mm behind the picture plane. So this problem is given. I will explain step by step and how to draw this in the top view and in the front view, and how to draw the horizontal line, ground line and the picture plane, etc. I will explain one by one. So I will minimize this question here just for the reference. So in the problem, first they have given us the square prism details, which consists of the base, side and the height, and how it lies with reference to the picture plane. It is given in the first line. In the second line, it is given us the station point is 30 mm in front of picture plane and 80 mm above the grain plane and lies in a central plane 40 mm to the right of the prism. Okay. So before going to draw, first we have to draw the front view and top view. So let's segregate this perspective projection. So whatever drawings that we are going to draw, it should be in a third angle projection. That means the front view is drawn below the reference line and top view is drawn above the reference line. So first, if you are an observer, so below is a ground plane and above is a horizontal plane. If you draw, first what line that you could able to see is the ground line, and this is the line that is ground line GL. So here the statement that is given as the station point is 30 mm in front of picture plane and 80 mm above ground plane. So 80 mm above ground plane is the station point, that is the eye contact. So it means that 80 mm above the ground plane, it refers to the horizontal line. So therefore now I am going, because the horizontal line could be seen only in the front view. So now I am going to just draw a horizontal line. So this is the horizontal line. This horizontal line is drawn, that is 80 mm. So 80 mm above the ground plane, that is known as the horizontal line, and lies in the central plane 40 mm to the right or left. It depends upon the station point. So this is the front view. Okay. Now we are going to focus on the top view. So first, before going to start the top view, I will just imagine the picture plane, because whenever if you look above the perspective projections, the plane which is perpendicular to the ground plane, that should be seen in a straight line, that is the picture plane PP. So here in this drawing, what the statement has been given is the station point is 30 mm in front of the picture plane. So below this picture plane you have to draw one line. This line is 30 mm. So this line is 30 mm in front of the picture plane. So this is the basic foundations, which is the very fundamentals before going to start the perspective projection. So once again I will recall. So square prism details that will further it will proceed in the next step. So the ground line should be drawn first, and the 80 mm above the ground line means it is the horizontal line that is drawn first, because this is below the reference line, that is front view should be drawn below the reference line XY, and above the reference line, that here you have to draw the top view, that is the station point is 30 mm in front of the picture plane. First picture plane should be drawn, and in front of the picture plane we have to draw on another line, that is 30. So this is the format structure of the perspective projections. Now I am going to focus on the prism. So the square prism of base side 40 mm and height 70 mm, it is given. So when you see the square prism, so only in the top you could able to see the square. So for example, it is a perfect example of a square prism. So in the top you could able to see the square face, and front you could able to see the rectangular face. So now I am going to draw the top view first, because in the top view I could able to see the all the 4 equal sides of the square. So but the square prism of base side 40 mm rest with its base on the ground such that one of its rectangular faces is parallel and 10 mm behind HP. So if this is the picture plane, for example, if this is the picture plane and this is the rectangular face, this rectangular face is 10 mm behind, this rectangular face is 10 mm behind the picture plane and 10 mm behind the picture plane, and if you look at from the top, so the square faces could be able to visible, and the square faces, one of the bottom side of the square is 10 mm behind the picture plane. So this is the picture plane. Now I am going to draw it in another color. Okay, so behind this I am going to draw a square. So this is the square, and here the one of the side it is 10 mm. So one of the edge of the square prism is 10 mm behind the picture plane, and the base side is 40 mm. So therefore others are represented, it is square 40. So all the 4 sides must be drawn equal using some proper mini drafters or measuring equipments. So all these squares should be drawn with all the 4 sides should be equal, and each one should be perpendicular to each other, and this is the way to draw the top view of the square prism. So for square prism, 2 sides are there, top face you are having one square, bottom you are having one square. Now I am going to name it as ABCD, A1, B1, C1, D1. So top face I am name it as ABCD, and bottom I am going to name it as A1, B1, C1, D1. So when I look at from the top, I could able to see A, because it is a top view. Therefore I have to mention this naming as ABCD. If it suppose if it is the front view, I could name it as A dash, B dash, C dash, D dash. So here I have mentioned it as A, B, so it is mentioned it as A, B, C, D, and the bottom side is mentioned as A1, B1, C1 and D1. So this is the representation of the square prism in its top view. Now I am going to represent the same prism in front view. In front view, I could able to see only the rectangular faces. So here the height of the rectangle is 70 mm. So now I am going to make a projection lines. So the square projection is drawn here, and I am going to draw the front view. Front view is this rectangular face, and the rectangular face of the prism. So this is the front view of the square prism. Okay. So this is the thing I am going to draw. So when I am going to look at from this directions, so here this is A dash, and this is B dash, and here this is A1 dash, and this is B1 dash. These are all visible. So why I mentioned dash means it is front view. That's why I am drawing this front view below the reference, because it is a third angle projection. So A dash, B dash, A1 dash, B1 dash is visible, and behind this B dash, what is there? That is C dash is there, and behind A, D dash is there, and behind this B1 dash, C1 dash is there, and behind A1, D1 dash is there. And this is the representation of the square pyramid front view. So the first sentence is completed, that is the top view and the front view of the square prism has been drawn successfully. So such that the rectangular face is parallel and 10 mm behind the plane. The first statement is completed. Then we have to locate the station point. The station point is 30 mm in front of the picture plane, 80 mm above the picture plane, and the last one is the lies on the central plane, 40 mm to the right of the corner of the prism. So first you have to locate the corner of the prism. So here you are having two corners. So what are the two corners? So this is corner number 1. So this is corner number 1. This is another corner. So here about these two corners, what happened is 40 mm to the right of the corner of the prism. So here this is the right hand side. So from this corner of the prism, I am going to take a stationary point, that is 40 mm to the right. So therefore I am going to draw a station point. So I am going to draw a station point here. The station point should be like this. So this should be 40 mm. So now read the statement again. And lies in a central plane 40 mm to the right of the corner of the prism. So this is one of the corner, and the central plane is located 40 mm to the right of the corner of the prism. So it indirectly refers at this point you are having the station point. So this is the station point 1 and this is the station point 2. The station point which is represented, the top view is mentioned as S and the front view is represented as S dash. So these two are the station point, which is 40 mm to the corner, right side corner of the extreme end of the prism. So now based on the details I have marked all these terminologies. Now the next step is, based on the procedures, we have to complete the three-dimensional view of the perspective projections. Okay, what is the procedures? So the procedures number 1 is, so here we have to draw several projection lines. So first I will explain this. From A1 we are going to join this A1 to S by using a small projection lines. So A1 to S should be connected. So similarly in the front view locate the point A1. So this is A1. So from A1 you have to connect this with S. So this is the procedures. So now look at the point of intersection on the picture plane. So it should be referred as in this blue color. So this projection line, this is the perspective project. This is your PP. So this projection line compulsorily it should intersect in the picture plane at this particular point. So locate this point. So from this point of intersection you have to draw one straight projection lines which should intersect at the line which is always we have already drawn from A1 dash to S dash. So look at the procedure correctly. From A1 you have to draw one projection lines which should be connected from A1 to S. Similarly from A1 dash to S dash another projection line should be connected, and in the picture plane you have one point of intersections. Particularly locate that point of intersections. From that point of intersections point you have to draw a projection line. So again from this point I am going to draw a projection lines which should be parallel to the other projection lines, and these projection lines intersect at particularly this line, and here you are having one point. This point is known as A1. Can you understand this? And similarly repeat this for another point, because in square prism you are having 8 points A, B, C, D, A1, B1, C1, D1. So for 8 points you have to draw another 8 projection line. So now I am going to repeat this for the another point, that is B1. So from B1 you are going to draw one straight line, and again from B1 dash you are going to draw another one straight line. Now you can identify the point of intersection. So this is the point of intersection. So now from B1 to S I am going to draw one projection lines, and you can get one point of intersection. From this point of intersection again you are going to draw one projection line. Okay, so from this point of intersection I am going to draw another projection line, and it should interconnect with this B1 to S1 dash. And now you can locate the next point. The name of this point is B1. So A1 is located, B1 is located. Similarly you have to locate all the 8 points, that is C1, D1. So similarly I am going to locate the next point, that is from C1 to S1, and here also again C1 to S1, and here you will get the point of intersection like this, and again from this you are going to draw one projection line in the C1 to S1 dash, and here I can get the point of intersection, that is C1. So this is A1, B1, C1. So similarly from D1 I am going to locate this, and similarly from D1 already on line is there. So here you are having one point of intersection line, the point of intersection with respect to picture plane, and from this I am going to draw one projection line, and it interconnects at this D1 to S1 dash line. Okay, this is interconnects with D1 to S dash line, and here you can locate the point D1. So now you can connect all these 4 lines, that is the base of the square prism. So that is A1 to B1, B1 to C1, C1 to D1, and again D1 to A1. So this is the base of the square prism. Similarly we are going to complete this for the other 4 types of line, that is A, B, C, D, which is the top face of the square prism. I will draw it correctly. So A to S, that is the first face, and here it is the connection line. Similarly I am going to draw the projection lines from the top view, that is A to S, B to S. Okay, so now we are going to get the point of intersections, that is A1 dash, and this point is intersected at this one, and this is A, and here this is point B. The point B is interconnected at this point, and this is point B, and this is for point C. The point C is interconnected here. This is point C, and here this one and this one is interconnected at this point, and this is point D. Now connect all these 4, that is A to B, B to C, C to D, and again A to D. So now the base of the square prism and the top face of the square prism both are completed. Now it's our duty to connect all these lines, that is the rectangular faces, that is A to A1, B to B1, and C to C1, and D to D1. So finally we are going to get the final output, that is if you connected all these 4 edges, the final view it should represent only thick visible lines. So you have to take your H pencils, and the final outcome should be highlighted, that is the final outcome of the perspective projection 3-dimensional drawing should be highlighted with thick lines. So again A to B is interconnected, B to C is interconnected, and here the top face you could be able to see all the 4 faces, and here A1 is connected, B1 is connected and C1 is connected, and this is the final output of this particular drawing. So draw the perspective projection of the prism. So this red color 3-dimensional view is the final outcome. So base is A1, B1, C1, D1, top one is A, B, C, D. So this is what we have to line, and we have to neglect the vertical edges from D1 because it should be visible only at the back side. So that edges should be hidden, that is known as hidden line. So the hidden line is no need to draw in a very thick manner. So only these lines represented in red color, that should be highlighted as the final output one, and this is the output of the perspective projections. So thanks for the opportunities.